Right, here we go. We are starting Unit 5. Sorry I couldn't be here today. Um, let's get to it. 5.1, this is going to be all about isosceles triangles. And we've already talked about isosceles triangles. What are isosceles triangles? What does that mean? That's just going to, what is that going to mean? That's going to be two sides are congruent. Two sides are congruent. And we actually proved that two angles are congruent. All right. So if I say, I saw the triangles isosceles, we know for a fact that two sides are going to be equal and two angles are going to be equal. We don't have to do anything else with that. All right, but we can do better. All right, so maybe there are some other ways. So if I say something is an acute triangle, what that means is all three angles, whoa, are acute. Well, if all three angles are acute, that means they are going to be less than 90 degrees. Every angle, all three angles are going to be less than 90 degrees. If I call a triangle an obtuse triangle, that means one angle is obtuse. So we proved back in Unit 4, you can only have at most one obtuse angle. You can't have multiple. That wouldn't make any sense because then you're going to go over that 180 degree limit that we have with triangles. All right. Um, if I have a triangle that is a right triangle, that means one angle is exactly 90 degrees. All right. I don't care about the other two angles. I know that the other two angles are complementary. I just know at least one of those angles is a 90-degree angle. All right. And then the last one is an equal angular triangle. We've actually proved this one, but that means all angles are 60 degrees. All right. All three of them. And we proved that one as well. You can do a little algebraic proof to convince yourself that one, or just think about the names equal, angular, equal angles, right? So in an equal angular triangle, all three angles are 60 degrees. All right, so those are kind of four ways that we can classify triangles based on just their angles alone. All right, if I want to classify triangles by their side lengths, all I have to do is say equilateral. An equilateral triangle is all three sides of a triangle are congruent. All right. So just one thing that I do want to point out is that just because uh, angles in a triangle add up to 180, a lot of people want to say that all the sides add up to 180, and that's not always going to be the case. So that's just something to kind of keep an eye out for, right? So angles add up to 180, side lengths, that is not necessarily true. All right. If I classify a triangle by its sides, if I say we have an isosceles triangle, I talked about this one earlier, we just have two congruent sides. All right, and we call these the legs. All right, so we've defined these earlier. We defined these in Unit 4. The two congruent sides are called the legs. The non-congruent side, that is called the base. All right, and then the last one is a scalene triangle. So all three sides have different lengths. All right, so there's going to be three kind of keywords that you're going to need to know for this unit. And really, there's seven right off the bat: acute, obtuse, right, equal angular, equilateral, isosceles, and scalene. All right, so now let's just go ahead and look at this picture here. We want to classify what this picture is, what type of triangle this is, based on all of the stuff that we have. All right, and first things first, all we know is that we have two congruent sides. All right, well, since we have two congruent sides, that is an isosceles triangle. All right, if we classify it by the angle, well, here's the angle. It's 130 degrees. That's an obtuse angle, so this is an obtuse triangle. All right. So if we were to classify this triangle altogether, this would just be an obtuse isosceles triangle. All right. The next one. Look at all the angles. Those are all acute angles. All right. So it's definitely an acute triangle. Now, there are no tally marks on this picture, so I don't know that any of those side lengths are the same. So they could be, but we just do not know for certain. Well, actually, we do. We'll get into that later. But I'm going to go ahead and call this one a scalene. All right, so it has three different sides or three non-congruent sides, all acute angles. So that's an acute scalene triangle. All right, the next one. If we look at the angles, this is equiangular. All right, that's an equiangular triangle, and all three sides are congruent. So this is an equilateral. All right, so you have the tally marks or the tick marks, so we know they're all congruent. They're telling us, hey, every single angle is congruent, every single angle is 60 degrees, so it's both equiangular and equilateral. All right, and the last one here, we have a right angle, so this is a right triangle. All right, and we also have two tick marks on here, so we know that this guy is isosceles. Two sides are congruent, so we're going to say isosceles triangle. All right, and that one's done. All right, the next one, if a triangle. So these problems, these are always, sometimes, or never. I'll tell you right now, you're going to have at least one of these, probably three of these on your test, maybe even on your quiz. All right. So put a little star next to these. These really make you think. So if a triangle is isosceles, it is always, sometimes, or never equilateral. So let's think about, what does isosceles mean? So isosceles means at least two sides are congruent. All right, so that right there, that's an isosceles triangle. Now, this third side here, we don't necessarily know how long that is. All right, so sometimes it could be congruent, sometimes it's not congruent. So this is actually a sometimes. All right, so as a matter of fact, I need to go back up here and change this definition. If I look at an isosceles triangle, I should have said at least two. So actually, let me go ahead and fix that. You're going to be mad at me, but that's okay. You'll forgive me. All right, so at least two congruent sides. All right. So it could be two sides, it could be all three sides. So sometimes isosceles triangles are equilateral. All right. But if we look at the next one, if a triangle is equilateral, it is always, sometimes, or never isosceles. So again, if we just look at the last one, we said every single isosceles triangle sometimes is equilateral. Therefore, every single equilateral triangle is always isosceles. Mhm. And there we have it. On to the next page. So, looking at these isosceles triangles, um, I should have done this first, but we already did this in Unit 4, so I'm not going to take too much time on this. So I will say the congruent sides. The congruent sides are called the legs. So we have a leg here. We have a leg here. All right. The next one says the non-congruent congruent sides. The non-congruent side is the base. So we'll call this guy the base down here. All right. Let's see here. What goes in these next two blanks? The blank sides form the, what do I have here? I think I have the two congruent sides. The two congruent sides form the vertex angle. All right, so our two congruent sides are up here. This is our vertex angle. All right, and the last one, the other two angles down at the bottom, we call these the base angles. All right, so it's attached to the base, so that is a base angle. All right, so that's pretty much everything we can say about an isosceles triangle. And then we already did this. The isosceles triangle theorem. I'm not going to prove this one, so we already proved this. It's if or in. How about this? If a triangle is isosceles, it's always got to be an if-then statement. If a triangle is isosceles, right? Then, if triangle is isosceles, then the base angles are congruent. If a triangle is isosceles, then the base angles are congruent. All right, so basically, if two sides in a triangle are congruent, then two angles will be congruent, right? So that's just kind of another way that you could think about this. So you can always say, like in a triangle, if two sides are equal, or we'll say congruent. In a triangle, if two sides are congruent, then two angles are congruent. All right, kind of ran out of room there. All right, the converse. Converse of the isosceles triangle theorem. So remember, converse goes Q, arrow, P. All right, so we're going to say if in a triangle, if base angles in a triangle, if base angles are congruent, then two sides are congruent. All right. Let's see here. So the bases and the legs are always going to be opposite of one another here. So I probably should have put that in there. Base angles are always going to be opposite from the legs. So we just kind of draw a picture up here. All right. So those are going to be congruent. All right. Let's see here. Using the figure shown below, find the value of x and the three side lengths. All right. So the first thing I notice in this picture is we do have an isosceles triangle. All right, we have two congruent angles. All right, so the opposite sides are congruent. All right, you're gonna have to forgive my handwriting on these. I'm writing on the screen. All right, let's see here. So we have two congruent sides. Well, anytime you have two sides that are congruent, set those expressions equal to each other. So we know 8x minus 1 equals 4x plus 5. All right, and then we can just solve it. All right, the 2x plus 11, don't worry about that. All right, we'll come back to that. Let's solve for x first. Subtract the 4x on both sides. Add the 1 to both sides. We're going to say 4x equals 6. Divide the 4 over, and we have x equals 1.5. All right, so we got a decimal. Big deal. Get over it. Um, all you got to do is plug it in. 1.5 times 8. What is 1.5 times 8? I think that is 12. I need a calculator. All right, so 12 minus 1 is 11. So this is 11. All right, here, we'll plug that in. 8 times 1.5 minus 1, that equals 12 minus 1, which gives us 11. All right, I don't even need to do any real math on this one because I already know the next side needs to equal 11. But if we wanted to confirm that, we're just going to say 4 times 1.5 plus 5. 4 times 1.5 is 6, so this just equals 6 plus 5, which of course gives us 11. All right, and then the last one, this just gives us 3 plus 11, which of course is 14. All right, and that's all we have to do there. All right, on to the next one. Complete if angle 1 is 20. All right, so all we know is that angle 1 is 20 degrees. So here's what I'm gonna do. I'm just gonna put a 20-degree right here. All right, so we need to be careful on this problem because there's really no information, no written information. We have to look at our picture for clues. If we look at just that green triangle there, it's an isosceles triangle. All right. Well, hey, since it's an isosceles triangle, we know that base angles are congruent. So angle 2 is also 20 degrees. All right. Well, since we have two angles that are 20 degrees, we get this top angle for free. Don't forget about the triangle sum theorem. All right. If you want to call this x, we could say 20 plus 20 plus x equals 180. All right, and then you just solve that. 40 plus x is 180. We know x equals 140. All right, so I'm going to get rid of this x down here, and I'm just going to put a 140. All right, so now where can we go from here? Let's not forget, of course, about linear pairs. All right, we know angle 3 here has to be 40 degrees, right? Because 140 plus 40 has to equal 180. All right, let's see here. Where can we go from here? If I look at this red triangle now, all right, that's also an isosceles triangle. All right, so what does that tell us about angle 4? Oh, well, angle 4 is also going to be 40 degrees. And once again, we can use the triangle sum theorem to figure out this guy down here. 40 plus 40 is 80, so this angle has to be 100 degrees. All right, and last but not least, well, maybe least, there we go. All right, these three angles here have to equal 180 degrees. So we have 100, we have a 20. So let's just say like, how about y plus 100 plus 20? That has to equal 180 because that makes a straight line. All right, 120, we're gonna have y equals 60. So this right here is a 60-degree angle. And there you have it. There are all five of your angles. All right, so let's just recap. Let's write all those down. How did we figure out angle 2? Angle 2 we knew was an isosceles triangle, so it had to be congruent with the given information. Angle 3, we needed to find that vertex angle of 140. Then we used linear pairs to get a 40-degree angle there. Angle 4, again, that red triangle is isosceles, so we knew those base angles are congruent. Um, then angle 5, again, we had to use triangle sum to get that 180 degree, I'm sorry, to get the 100-degree angle on the vertex. And then we use the idea of not necessarily a linear pair. I don't know if we could maybe call it a linear triple, I guess. All three of those angles downstairs had to add up to 180 degrees. All right, so that's how we found those angles. All right, next one. A triangle is equilateral if and only if it is equiangular. All right. So when we looked up here, we said isosceles triangles. The isosceles triangle theorem said if a triangle is isosceles, base angles are congruent. And then we said, all right, in other words, if two sides are congruent, then two angles have to be congruent. The equilateral triangle says, hey, if all three sides in a triangle are the same, then all three angles in a triangle have to be the same. All right, so that's really all that one says. So here's that this if and only if, this biconditional. This means both the original statement and the converse are both true. So we can say equilateral. Equilateral means equiangular. All right, and then we take the converse of that. We could say, okay, equilateral, I'm sorry, equiangular. All right, that means equilateral. All right. Now the next one. Each angle in an equiangular triangle measures 60. We have proven this one multiple times. So if I want to throw an x here, and an x here, right? We know we can do that. We know that all three of these angles are congruent because that's the definition of equiangular. Let's just say x plus x equals 180 degrees. There's that triangle sum theorem. And then we're just going to do a little bit of algebra from here. 3x, combine your like terms. 3x is 180. Divide both sides by 3. You're going to have x equals 60. All right, so there are your equilateral triangles. All right, we are almost done. So a little bit of algebra here. So remember, honors geometry algebra is fair game. So let's kind of take a look at this one. An equilateral triangle. All right, so since it's equilateral, that means it's also equiangular. Since it's equiangular, I know angle D equals 60 degrees. I know angle E equals 60 degrees. All right. That is useful because what can I do with these two things? I can make some equations here. So I know, well, hey, x plus y equals 60. I also know 2x minus y equals 60. All right, so there's two equations. We have the first equation had both an x and a y in it. Second equation, same thing, has an x and a y. Anytime you have more than one variable, you need the same number of equations. So since we have two letters, we need to have two equations here. All right, and this equation, fortunately, this was kind of a nice one because notice how the y values, they're both ones. It's a positive 1y and a negative 1y. So what we can do is we can add these straight down. I would really recommend you always add. All right, I wouldn't ever subtract on these because then we could potentially lose double negatives, and that's just something that mistakes can occur really easily. So we try to avoid those when we can. All right, so add straight down. X plus 2x equals 3x. 60 is 120, so x is going to equal 60. All right, seems easy enough. Now, pick one of the angles. Doesn't really matter. I think the top one is a little bit easier. That it's a more simple equation, so we know x plus y equals 60. All right, and then just plug that in. We have 60 plus y equals 60, and then solve it, right? Y equals 0. All right, so is that okay? Is y equals 0, a good answer? Well, I made a mistake, so that's why. So I'm gonna erase this. I can't wait for you guys to point that out. All right, I don't feel like making this video, so you're gonna have to sit through that. But you know what? Mistakes happen as long as we catch them. Because 120 divided by 3 is 40. All right, take two. I'm still gonna pick the top equation. That's still that x plus y equals 60. All right. Then I'm gonna plug in the 40 again. So we still have 40 plus y equals 60. Therefore, y equals 20. Right? Yikes. But hey, we fixed it. We solved it. It's good. All right. Don't leave that comment because I fixed it. All right. Let's see. You can plug it back in. You can check. All right. Well, let's just do that. 40 plus 20. That equals 60 for sure. So that's good. 2 times 40 minus 20. 2 times 40 is 80 minus 20. That gives us 60. That's also good. All right. So that one is done. Right. So there you go. So x is 40. Y is 20. In algebra, they always say you should write your answers as an ordered pair. So it would look like that. All right. If you're in my class, if you just circle your answers, I'd be okay with that. All right. On to the next one. Unless my computer crashed. It's just not looking good. All right. Given angle 1 is congruent to angle 2, we have to prove. Uh-oh. Another proof. All right. So I'm going to write down our statements. I'm going to write down our reasons. We need to prove that segment OK is congruent to OJ. All right. So angle 1 is congruent to angle 2. Why do we know that one? Well, that's given. That is our free information, right? We always have to start out with some piece of given information in order to prove something else. All right, now, what do we need to do here? I got some ideas, so if you want to try this one on your own, pause the video. But I think a good step 2 is let's look at our picture and see what we can get. I know that angle 1 is congruent to angle 3. All right. Why do I know that? Oh, because those are vertical angles. All right. So unit 2 throwback. Well, hey, if you look downstairs, angle 2 is congruent to angle 4. Why do we know that? That's also a vertical angle? So I'm going to include both of those in the same step here. All right. So here's what we have. We started off with angle 1 equals angle 2. That was the given information. We just showed that angle 3 is equal to angle 1, and we just showed angle 2 is equal to angle 4. All right, so now we can use our leapfrog property. Just make the connection that angle 3 is congruent to angle 4. All right, so that is, of course, the transitive property. So let's say, all right, angle 3 is congruent to angle 4. All right, that is transitive. almost done. Last step here. Actually, I'm sorry, it's not the last step. Let's go angle four, or step four, how about? What can we say about this triangle? Let's say triangle, let's say OJK is isosceles. All right, why do we know that? We know we have two congruent angles, right? Well, since we have two congruent angles, that means we get two congruent sides. What are those two congruent sides in this picture? That is segment OJ is congruent to segment OK. All right, that is just the definition of isosceles triangles. Definition of isosceles triangles. And that one's done. Now, if we did want to be a little bit more rigorous, we would probably have to say triangle OJK is isosceles with like angle J and K, or angle 3 and angle 4 being the base angles. Since those base angles are congruent, we know that the sides opposite those angles are congruent. So if we were being super strict, you would probably want to do that. But this is probably okay. I'm not that picky. All right. Let's see here. Next one. The exterior angle of a triangle. All right, so this theorem says the measure of each exterior angle of a triangle equals the sum of the measure of the two non-adjacent interior angles. We could prove this one. So why don't we call this angle 4? All right. So I'm going to prove this without words. All right, we know angle 2 plus angle 3 plus angle 4 equals 180. Why do we know that? Because it's just a triangle. All right. We also know angle 1 plus angle 4 equals 180 degrees. Why do we know that? Because those are a linear pair. Well, hey, both of these kind of expressions here, both of these expressions equal 180 degrees. So here's what I can do next. I'm going to say angle 2 plus angle 3 plus angle 4 equals angle 1 plus angle 4. All right. And if you look at that expression, both sides of the equation have an angle 4, and those just cancel out. So we could say angle 2 plus angle 3 equals angle 1. And that is the exterior angle theorem of a triangle. All right. So if you have that exterior angle, so basically, if I take this triangle, I probably should have explained this first. Sorry. If I take this base of this triangle, all right, and I just kind of extend the thing out, angle 1 is an exterior angle. All right, I can use it any side if I want to. Maybe I could draw another one going up here. All right, this would be like angle 5 up here. Right, so those are the idea of exterior angles. Basically what it says is the measure of each exterior angle of a triangle is equal to the sum of the measure of its two non-adjacent, right? So if you look at angle 1 and 4, those are adjacent angles, they share a side. But angle 1 is not adjacent with 2 or 3, right? So that's why we take angle 2 plus angle 3, and that is going to equal angle 1, right? So if we were to look at that angle 5, we could say, okay, angle 5 in this case equals angle 3 plus angle 4, right? So if we wanted to do that, we could say angle 3 plus angle 4 equals angle 5. If we wanted to draw a third one going down here, we could do the same thing. All right, so that's what the exterior angle theorem says. All right, if you remember that one, it's just kind of a quality of life. You could absolutely get by without remembering that one, but it is kind of useful here. All right, because what I can do is I can take angle A plus angle C. I know that is going to be equal to angle CBD. All right, so let's just plug in the expressions. Well, angle A, that is just x plus 40. Angle C is 3x plus 10. And angle CBD is 6x. All right, that's all we're doing, right? We're using that exterior angle theorem from up top to get this, kind of expression, right? That's the hard part about geometry is all the algebra. It's using the ideas and the concepts of geometry to make these algebra expressions. All right. And then we solve this. All right, so you got 4x plus 50 equals, how about a 6x? That could have been bad. 6x. All right. I'm going to subtract the 4x over. We're going to have 50 equals 2x, therefore x equals 25. And then we just plug it all in. So let's see here. 3 times 25 is 75 plus 10. This gives us an 85. All right. If we go to angle A, that's x plus 40, or 25 plus 40, that's 65. So here, let's just do this. 85 plus 65. What does that give us? That gives us 150. We already know this angle should be 6 times 25. If we plug it in, that also equals 150. All right, so that theorem checks out. All right, and there we have it. Let's see here. I think I have two more. All right, last kind of section here. So what do I want to say? How about the angle bisector? That's what I want to put here. The angle bisector. The angle bisector of the vertex angle of an isosceles triangle is the perpendicular bisector of the base. All right, so we've mentioned this before, but it's been a while. So perpendicular bisector. Perpendicular means you're going to make a 90-degree angle. Bisector means it goes through the middle. All right, so a perpendicular bisector will say, how do I want to say this? A perpendicular bisector I'm going to say a perpendicular bisector hits a midpoint. It's going to hit a midpoint at a 90-degree angle. All right, so let's just kind of recap what we have here. The angle bisector of the vertex of an isosceles triangle. All right, so we have to have an isosceles triangle. So that means two congruent sides. All right, if our triangle is not isosceles, this does not work. So I guess really the very first thing we need to verify is, hey, do we have an isosceles triangle? If that's true, if we do have that angle bisector, then what's going to happen is it's going to hit this angle down here at 90 degrees. Or I'm sorry, it's going to hit this midpoint right here at 90 degrees. All right, so here's just a couple examples of that. So we for sure have an isosceles triangle. All right, so since that's an isosceles triangle, this is an angle bisector right here. All right, so that tells us that this point, that's a midpoint. All right. Well, since that is a midpoint, that tells us that these two segments here are congruent. So that means, y equals 5. All right. Since it's an isosceles triangle and an angle bisector, we know that this is a 90 degree. All right. So we know, x equals 90 degrees. All right. Let's see. What else do we know? This is a right triangle. So we know that z and 40 are complementary, but let's just say we kind of forget that for now. Let's just say, okay, z plus 40 plus 90 equals 180. right? So there's your triangle sum, and we could just say, okay, z equals 50. All right. Hey, these two triangles are actually congruent. These triangles are congruent by the side angle side theorem, right? They have a reflexive property. They are congruent by the angle angle side theorem, the angle side angle theorem, right? So actually, these are congruent by pretty much all of the ways that we know. So we also get that this is a 40-degree angle. They're not asking for it, but we can certainly put that down. All right, last one here. Hang in there. I know this is kind of a long video. Sorry about that. Um, let's see here. Same idea. We have a isosceles triangle. We have this angle bisector in here. I give you that that's 90 degrees. So we didn't even really need this right here because we could have established that. But x equals 90. Oh man, I tell you, why did I do that? Everything is congruent. 3y equals y plus 2. And just solve it. 2y equals 2, y equals 1. And then these two angles, we could prove that these triangles are congruent. So by CPCTC, z equals 30. All right. I think that's all of them. All right. And we are done. And this section is finished. So that was section 5.1. Sorry that took a little bit. I made 2 mistakes in there. Count it. But that's all we got. So we'll see you guys in the next one.